Picture this. After a grueling decade of anticipation, Russia's homegrown Soyuz 5 rocket, affectionately dubbed Irtysh after the mighty river snaking through Russia and Kazakhstan, has finally made it to the launch pad. It's a moment of triumph, yet it stirs a whirlwind of questions about its place in an ever-evolving space landscape. But here's where it gets truly intriguing. What if this rocket's arrival signals not just progress, but a pivotal test of Russia's space ambitions against global shifts? Let's dive in and unpack the details, making sure even newcomers to rocketry can follow along. At its heart, the Soyuz 5 is designed to fulfill a critical role in Russia's space strategy. Its first stage draws power from a single-rode 171 MV engine, a powerhouse that delivers 3 times the thrust of SpaceX's Raptor 3 engine when operating at sea level. This engine belongs to a renowned family of liquid-fueled rockets, widely regarded as the most potent in the world for this technology. What makes it stand out is its reliance solely on Russian-made components, emphasizing national self-sufficiency in an era where supply chains can be unpredictable. For beginners, think of it like having a custom-built sports car that's engineered to outperform rivals without borrowing parts from overseas manufacturers. It's all about that pure, homegrown edge. Beyond standalone missions, Russian officials envision the Soyuz 5 playing a starring role as the boost stage for the Super Heavy Yenisei rocket. This futuristic beast is earmarked for ambitious human lunar expeditions, potentially carrying astronauts and supplies to the moon's surface. However, the Yenisei project feels like a dream perpetually on hold, loudly proclaimed as a top national goal, yet it languishes in a murky phase of development that drags on without clear breakthroughs. It's a classic case of big talk meeting bureaucratic inertia, leaving us to wonder if this lunar giant will ever take flight. And this is the part most people miss. Despite the Yenisei's uncertainties, the Soyuz 5 itself is very much a reality, poised for its maiden launch in the coming month. The big question looming over it? In a crowded marketplace of rockets, who exactly will buy what it has to offer? To grasp this, let's compare it to Russia's existing lineup. The tried-and-true Soyuz 2 handles crew transports and cargo runs to the International Space Station, ISS, along with lofting smaller satellites into orbit. It boasts roughly half the lifting power of the Soyuz 5. Then there's the Angara series, which has been rolling out over the past decade, providing a range of options for various payloads. The Soyuz 5 neatly bridges the gap between these two, with the capability to deliver about 18 tons of cargo to low Earth orbit, LEO. That's the zone just above our planet, ideal for satellites circling Earth in a matter of hours, like the ISS or communication relays. So, what's the demand for a rocket in this sweet spot? It's a contentious point that sparks debate among space enthusiasts and industry insiders. On one hand, the market for geostationary satellites, those parked high up in a fixed position relative to Earth, once the mainstay for Russia's Proton rocket, has plummeted in recent years. These satellites are crucial for things like broadcasting TV signals across continents or monitoring weather patterns, but with data demands shifting to faster, lower-orbit constellations, think of Starlink Swarm, the need for heavy lifters to geostationary spots has dwindled. It's like the decline of floppy disks in the digital age, once essential, now mostly obsolete. Adding fuel to the fire is geopolitics. Russia's invasion of Ukraine has effectively blacklisted many Western satellite operators from using Russian launch services, due to sanctions and ethical concerns. This creates a self-inflicted wound, as if a chef poisons their own kitchen. But here's where controversy brews. Some argue this isolation could force Russia to innovate and find niche markets, while others see it as a fatal flaw in an interconnected space economy. Is this a temporary setback or a long-term barrier? The jury's out, and it invites passionate opinions. Compounding the challenge is fierce international rivalry in the medium-lift segment. China is ramping up its government-backed and private launch capabilities, offering reliable and often cost-effective alternatives. India, too, is expanding its portfolio, with rockets like the PSLV and GSLV gaining traction for diverse missions. And for those prioritizing bang for their buck, companies or nations laser-focused on affordability, Russia likely can't compete with SpaceX's reusable Falcon 9, which slashes costs through reusability, much like refueling a car instead of buying a new one each time. It's a stark reminder that in space, price tags and reliability can make or break a rocket's fortunes. In wrapping this up, the Soyuz 5 represents a blend of engineering prowess and strategic hurdles, from its powerful Russian engines to its uncertain market fit amid global competition and political turmoil. Do you believe Russia can pivot and carve out a sustainable role for this rocket, perhaps by targeting emerging markets like small satellite constellations or deep space probes? Or is it destined to be overshadowed by more agile players? What controversial twists do you see in this story? Maybe a silver lining in self-reliance or a cautionary tale of isolation? Share your takes in the comments below. I'd love to hear differing views and spark a lively discussion.